Good morning and welcome to this seminar on green refineries for biorefineries for protein, bioenergy and biomaterials. We meet at a very special time in European history when the economy of the European Union is challenged by the consequences of Putin's invasion in Ukraine and the economic and supply chain war that has resulted is giving us in Europe a difficult time regarding supply of energy in particular, but also feedstock for the agriculture industry and some raw materials. We will not talk about all the problems here today, but we will discuss those that are related to what is supplied by the agricultural and forestry sectors, or what could be supplied by these sectors in a more efficient and for Europe beneficial way. We have a program that is governed by a very tight time schedule, but the organizers have decided to try to give some opportunity for discussion after the technical session on biorefinery systems in particular. So we might go on until 20 to 12 or even a quarter to 12, but hopefully not longer than that. So as a moderator, I do hope that the speakers today will succeed in meeting the extremely tough time schedule, considering all the content that I'm sure they would like to convey during their few minutes of attention at this seminar. I introduced it by describing it as a European challenge and common European interest in successfully developing these biorefineries. And as introducers of today's seminars, we have two contributions from the European Commission, one from the DG Agriculture and Rural Development and one from DG Energy. And I will first hand over the screen to Laurent Messier from DG Agriculture and Rural Development. So, the screen is yours.
So good morning, everybody. So I will indeed present you today the state of the art of EU plant proteins. I don't think you see my video, my screen, but never mind. I will proceed, and I will present you some highlights on the Commission work on plant proteins. The issue of EU protein deficit is widely known in the Commission. And the Commission is working on that, An important milestone was the 2018 report, and we'll talk about it in a few minutes. But before that, why our plant proteins are in the agenda? Because we need them, as you know, to feed our livestock. That's the reason. We are dependent on imported plant-based protein used for feed, in particular, soya from South America. The graph here describes the level of crude protein used for feeding our livestock in the EU. You see that roughage is the main source of protein for our livestock. That's the green bar at the left. It is green, which means it is produced in the EU. The second source of protein for our livestock comes from cereals, and most of it is produced in the EU. And the third column shows the extent of the EU dependency on soya meals. Why is it a problem to be dependent on imported plant protein? Because it comes from regions where soya is participating to deforestation, and it is our responsibility to avoid that our consumption contributes to negative environmental consequences in third countries. In case of political crisis, it also creates a problem of food security. You will before presenting you the activities of the Commission in the area of plant-based protein, let me put this topic in the broader context of the Green Deal presented by the Commission in 2019. The Green Deal includes many topics and actions, and among which agriculture, which plays an important role, in particular the farm to fork strategy, which is part of it. It was presented in May 2020. Even if the word plant protein does not appear in each page in the farm to fork strategy, it creates a favorable context for the development of EU-grown plant proteins. The Farm to Fork set many ambitious targets in that respect, and in particular, a significant reduction of fertilizer by at least 20% by 2030, and a reduction of nutrient losses by at least 50% by that date. And the Farm to Fork plans to boost organic production. Indeed, by 2030, organic production will reach 25%. That's the objective of agricultural lands. The Commission report, now we are going to tackle the Commission report published in 2018, highlights different market opportunities for for plant protein, and also shows some drivers for the development. And then at the end of the report, you will find some follow-up actions which are listed in the conclusion, and then we'll quickly go through them. The first action concerns the CAP strategic plan. The Commission planned in that report to help member states integrating plant protein interventions in the CAP strategic plans. All the plans, as you know, have been communicated to the Commission, which are examining them. Some of them have been approved recently. And the CAP provides several tools for the development of EU plant proteins. And it is the member states' decision to activate those tools or not. Among those tools, you find coupled income support for protein crops, where you have a special mechanism with a top-up by 12%. So you could go from 13% to 15% of direct payment. As you know, Denmark and Sweden decided not to support coupled income, to support protein crops through coupled income support. But at EU level, there is a 50% increase of the concern area and 26% increase of financial support. As a second tool, we could also mention the new tool, which are operational programs in other sectors, what we call other sectors. In the past, you had the possibility to subsidy investment and some interventions done by producer organization in fruit and vegetable sector, but also in a smaller scale in olive sector and hop sector. Now, this possibility is open to all the sectors. This is new, completely new. And it allows, action indeed in investment, but also crisis prevention, support and risk management. And we firmly believe that it could be useful for protein crops, in particular by making stronger the value chain, which is a recognized weakness of protein crop sector. But alas, only France, it's already good, but only France decided to activate it. And the other member states did not activate it for protein crops. And they will activate it by 2024. And the budget is not yet clearly defined. In the initial, CAP strategic plan, they mentioned 33 million euro per year for those programs. But we'll see very soon, I guess next year, they will have to modify the CAP strategic plan to make it more precise. And then another tool which is new are the eco schemes. And the eco schemes will certainly reward practices where you could find legumes which are favorable, as you know, for the environment. And then, of course, the actions or interventions under rural development remains, and is still an important tool. A second follow-up actions would concern market analysis and transparencies. There were several actions, in particular, since 2021, we collect prices concerning some protein crops and all seeds. and that gives us, a better understanding of the market, and we publish them on the DG Agri portal. And also, we worked together with Eurostat on the new regulation, which is called the CAIO regulation. That reform the statistics collection in the EU concerning agriculture, and there we'll have new information on the human consumption of protein crops, on also feed and bioethanol, and in particular we'll receive more detailed information on a more regular pace on grassland and grazing. That's quite important. And this SAIO regulation is nearly adopted. It should be adopted in early October or early autumn at least. And then there is another tool that has been developed in the framework of those transparency actions. That's the EU feed protein balance sheet. You see it here, and you find a link below. I hope that some of you know it. It's a tool where we list all the protein sources in the feed. We give some market and balance sheet information on those products, for all the detailed products. Here you just have the main lines, but in fact you have all the details when you go into the sheet, and you will see for all the products, all the cereals, wheat, all the oilseed, soya, different form of soya. You see all what is produced in the EU, imported, exported. But then what is interesting, what is used for the feed, and there is a coefficient, a conversion coefficient to calculate the crude protein content and volume for all those feed. And eventually we have a total figure that gives us the total volume of proteins which is used by our livestock in Europe. For the moment, as you see it, it's 73 million tons of crude protein, of which 56 are coming from the EU. And I recommend you to have a look at this tool. It's quite interesting. And of course, the development of sustainable food system will only take place if all actors invest in research and innovation. Only in the first Horizon Europe Work Programme 2021, 3 research program innovation directly concerning protein crops are planned for a total amount of 23 million euro. Yesterday, I attended to a kickoff meeting of the first program, which is called ValProPath, and that's just started yesterday, and it's the 10 million euro program. They have a website. I recommend you to have a look at it. And as actions also, it's a promotion of the benefits of plant proteins. That's a simple way to reduce our dependency on imported plant-based protein. But reducing also it would mean also perhaps a reduction of the livestock. But the reduction of the livestock is not a simple solution, and it will not be efficient as such, because we need to mention also to reduce, to change the consumer diet. If you do not change the consumer diet towards more plant-based diet, then we'll end up by importing more, livestock from third countries, and it will not help for the environment. It will not help, for the EU agriculture as such. So really, the first thing, as it is recommended in the Farm to Fork strategy, is to accompany the consumer to change its diet to a more plant-based diet with less red and processed meat, and with more fruit, vegetable, and pulses. This is why also the Commission announced in the Farm to Fork strategy that it will review its policy on the promotion, and we are in the process of doing it. It's not yet, the Commission hasn't yet published, its proposal in this regard. But I can tell you that we have the intention, but it should still be clear, to tackle a problem under the current legislation that where we finance, some. The promotion activities of agricultural products are not targeting all the products which are plant-based. There are some restrictions, and we'll go over that. Furthermore, when we promote pulses for human consumption currently, we mostly promote imported pulses, because 40% of the chickpeas are imported, 60% of the lentils are imported, for instance. So that we will have also to tackle, And then knowledge exchange, there's been a couple, of activity organized by the Commission, and there will be some more activity organized by the Commission in the future on the exchange of information on protein crops. Now let's have a very quick look, because I just have 3 more minutes, on the initiatives of different member states. Just to mention that some member states had strategy for developing the protein crops, and they've published them. I here mentioned France, Netherlands, Belgium, but then there is also, of course, the Danish one that was published in 2018, and also the German one. There was also the initiative, for instance, in Ireland on the climate change, where there were specific actions for the development of protein crops and pulses. And also, I would like to mention an opinion that is prepared for the moment by the Economic and European Economic and Social Committee, which is an opinion towards a sustainable plant proteins and plant oil strategy for the EU. I think it has some interesting and courageous, recommendation, and it should be published in October. And I recommend you to have a look at it when it will be published in October. And last, we have also other ongoing initiatives at the EU level. The first one would be the review of the 2018 report, the report for which I detailed the actions. And the Commission took the decision to revise this report. It took this decision in the food security communication published in March, but it's not yet clear or not yet defined, and we cannot yet talk about the form the report will take, the timing, and the scope. In any case, there is many stakeholders went to broader the scope compared to the 2018 report. It was really focusing on rich protein plan. So those plants with more than 15% proteins, and now this report will be extended certainly to all the sources that you could find in the protein feed balance sheet that's just showed you. There was also, I just mentioned that the PAP revision of the rules that was adopted last year, and also the legislation on feed additives. And then last but not least, we started in June a study here in the Commission to further identify the opportunities and limitation for diversifying feed sources, and of course with a particular regard to protein feeds. And this study should deliver its first results end of 2023. Thank you very much. And I guess we'll now give the floor to the next speaker, and perhaps the question later on, if I well understood.
Thank you very much, Laurent. I was a bit worried when you had many points left halfway through your presentation, but you did excellently in completing on time. And we did understand the European Commission focus on increased utilization of plant protein in an efficient way to improve the efficiency of the land use to food system of Europe. Now, the next speaker is also from the European Commission. It's Galin Genchev from DG Energy. I will hand over the screen and the loudspeakers to you.
Okay. I'll start basically by framing very quickly the policy context, also the different tools we have at a strategic level and a more legal level in supporting the biogas biomethane in terms of assessing its footprint, certifying traceability, etc., in order to make possible the production and consumption of these gases. And in the second part, I'll focus more briefly, but more concretely on the REPower EU action plan from May this year, which targets directly biomethane production with the aim to achieve a very ambitious but realistic target of 35 billion cubic meters biomethane production, annual production by 2030. Very quickly with the policy context, as you know, everything started with the Green Deal, whose ambition and aim was to make it possible to put all the preconditions in order to ensure the framework of being carbon neutral by 2050. It mainly entailed raising the different targets in the different sectors, as well as reforming the system as such in order to achieve efficiencies and support the implementation of the vision for the future of the energy system, which is a system primarily based on energy efficiency first principle, on circularity, on smart grids and interactions between the different energy systems, making it possible to achieve synergies in this way. Also on production and on cutting demand, optimizing the demand. The second pillar, obviously, deep electrification as main tool of the decarbonization, but very importantly, annulling the fact that full electrification would be either not possible or very costly, specifically in some areas, in the hard to decarbonize sectors, also remote geographical areas, like rural areas, for example, some of the rural areas. And this opened the room for renewable and low carbon fuels in the energy mix of the future, and respectively of gaseous, sustainable gaseous fuels. And this was also supported by the projections for 2050 consumption, which show that an expected 20% of gaseous fuels to be also consumed in 2050. And basically this put automatically the objective of how to switch from fossil-based to renewable and low-carbon gaseous fuels, where the expectation obviously is that the future mix will be mainly based on biogas biomethane, as well as renewable low-carbon hydrogen, as well as synthetic methane. This vision of the future was supported by the main strategic documents. Very briefly on the two, I'll just mention two of the strategic documents: the EU methane strategy and the energy system integration strategy. As you know, the EU methane strategy was about cutting methane leakages and emissions from the system, but it contained a very important area on agriculture, since half of the methane emissions are coming from agriculture, and mainly identified biogas production as a key mitigation tool, the mainstreaming of the biogas production based on waste and residues from agriculture as a main mitigation tool of cutting emissions, as a way of modern waste management, transforming basically a burden into an opportunity. The energy system integration supported this strategic vision, clearly promoting waste and residue-based production of sustainable gases. And in this strategic framework, the Renewable Energy Directive obviously plays a key role. The RED II version is from December 2018, and already there are clear supporting tools for the promotion of the biogas and waste-based biogas and respectively upgrading into biomethane through several tools. I'll very quickly just mention the main tool is basically the methodology, the way how the emissions are calculated, which is part of the sustainability criteria. They are basically inbuilt bonuses for waste-based production paths, which will make them, if they respect all the sustainability criteria, will make them either carbon neutral or if digestate or manure is used into carbon negative using the bonus. The definition, just something also probably important, the definition of food feed crops basically considers intermediary and cover crops as not main crops, which basically makes them an additional stream for generating biomass, which is not capped. As you know, there is a cap for the first generation biogas biofuels linked to transport, to a maximum of 7%. But since these intermediary cover crops are not considered main crops, this kind of debate, food feed against energy, is avoided this way. So since there is no additional land use of additional land triggered, then this is considered as sustainable additional biomass, and this may trigger, let's say, an additional also production of biogas. Unimportant also, it just proposed update of the Annex 9. As you know, this is an option under RED 2, where new feedstocks could be, let's say, proposed, and this also is an opportunity for advanced biofuels, but also for advanced biogas. As I mentioned, just for what in more concrete terms this bonus means, of 45 grams CO2 equivalent per megajoule if manure is used. Basically, an important work stream which is ongoing right now with the support of the Joint Research Center. We are reviewing the annexes 5 and 6, and there is part of the work will support the biogas production, specifically by introducing more several disaggregated values, which will help the better calculation of emissions, specifically on the manure. Also, some default disaggregated default values for feedstocks, which will help economic operators to better valorize what they are doing. An important pillar of our promotion system, I would say, is the certification, since without certification, biogas or biomethane cannot be called sustainable and respectively consumed. We recently validated the 13 voluntary schemes, recognized 13 voluntary schemes for certification of fuels in principle, and some of them, as mentioned on the slide, have on scope also biogas biomethane certification. We're also planning to upgrade the biogas calculation tool, which will make it possible for economic operators to actually easier calculate online their emissions, and this would help specifically, I would say, smaller producers. A very important aspect as well in our current system, we are working on it's under Article 28 of the Renewable Energy Directive. There is this obligation to set up a union database tracing transport fuels, renewable transport fuels. It will probably, if our proposal is accepted, will cover all end users in the end. So the scope will be updated. We are planning to put online this database. It's a huge work in a complex system, tracing basically the fuels as of January next year. And this basically would make it possible to trace the megawatt of biomethane in such a way, allowing the cross-border trade, since the system will the digital system will cover the integrated European grid as one mass balancing system. Very importantly, I have no time to enter into details, but very importantly, since also biomethane is probably about as an average 1% of the whole gas in the pipes, so it's not about tracing molecules, but it's more accounting the injected sustainable capacity and the consumed sustainable capacity through basically a mass balancing system. This would allow also cross-border trade among the member states, and will in this way promote the production and respectively make possible the consumption of biogas and biomethane in this case. We're also planning to basically connect this in cover with this digital system also neighboring countries, specifically once the situation, we hope, would allow to basically connect also Ukraine, as it's considered as one of the, let's say, neighboring countries with a higher untapped potential, about 20 billion cubic meters of biomethane. This is a potential that is untapped and could help basically the the energy independence of the EU as far as sustainable gases are concerned. And so now on the concretely on the REPowerEU action plan, basically the framework I just briefly described was there before the aggression of Russia on Ukraine and the drastically worsening geopolitical situation. So basically, in the case of biomethane, I would say this played a catalytic role, making the need even higher, and the pressing need for being more independent from Russia, and basically cutting progressively down to zero I think about 165 billion cubic meters of natural gas imported at the beginning from Russia. So as you know, the REPower action plan on biomethane was announced as part of communication and the package with the ambitious target of going up to 35 billion cubic meters from 18 already envisaged. So it's another 17 billion cubic meters per year to be achieved by 2030. The plan basically tries to. This is let's say an ambitious but realistic target as well. And in order to be able to achieve it, then there are many aspects that needs to be tackled on the not only on the production but also on promotion, also on financing, on permitting, etc. That's why this plan is very comprehensive, and I'll not have the time to go into details, but we'll see very quickly. Basically, the core objective is to further promote biogas, mainstreaming the untapped potential, mainly on waste-based, residue-based paths. This is expected to be, and specifically waste residue based from agriculture, as a main untapped potential. To basically, there are member states where this potential is quite well developed. So to go to the let's say to the maximum possible sustainable technical volume, but there are other member states where there's a huge potential which is untapped. So there are not so many projects, and that's why this is basically the main objective is optimize the production of biogas and put incentives for its upgrading into biomethane. Obviously, as well on direct biomethane production through gasification, but in any case, it's expected to be a minor source. A rough estimate of 35 billion euros investment needs. As I said, no time for going into details, but just there are 5 pillars in reality in the plan. The first is quite important. This is the strategic pillar, where the key actions also linked to green biorefineries, to rural areas and agricultural producers are linked, and basically there are three main streams I would mention. First of all, the biomethane industrial partnership. This is a partnership of the industry, of the whole value chain, organized by the European Biogas Association, but also this is open to any key stakeholders or interested parties, academia, NGOs, and this biomethane industrial partnership, we are about to finalize the preparation with the European Biogas Association. It will be officially launched as part of the Sustainable Energy Week. Copa-Cogeca on the agricultural side is active player there, as well as on the Commission side, DG Agri and DG Energy will be represented at the directors level in the governing board, together with industry and other also member states representatives. So this basically, this partnership will cover through task forces all the rest of the plan, and will try to support through data, best practices, best scenarios for production, and also business models. Will support all the other part of the of the plan, and very importantly and very specifically will support the member states, as one of the key task forces will be on developing manuals for developing national strategies on sustainable biogas and biomethane production, linked to what I just said, that there are some member states where the untapped potential is huge, so focusing on those member states obviously where there are no strategies. They're also with the idea that either to develop standalone or to have a dimension of this energy strategy into their national energy and climate plans in the ongoing update. Another important pillar of this another important stream in this pillar is obviously also the support to promote multi-stakeholder engagement. As you know, specifically for the remote areas, for rural areas, very often these projects, it's about involving a multi-stakeholder engagement, which is a precondition for that project, meaning local governments, meaning farmers, meaning let's say small businesses, also NGOs, to increase the acceptance of such projects. Therefore, this is key that good practices are basically streamlined there, and the role, just last thing, the role of farmers and their organizations is key. There are many actually agricultural cooperatives developing such projects. So the idea, as I said at the beginning, is basically mainstreaming what is this in order to actually attain the full sustainable potential for biomethane, for biogas and biomethane. Very quickly, as I said, the plan would cover different aspects in a comprehensive way. Reducing the red tape and speeding permitting is key in order to actually allow for quicker development potential. The cooperation neighboring countries, as I mentioned, Ukraine will be a key partner there. There's some preparatory work on the certification, including Ukraine in the future in the traceability system, as well as lifting some regulatory barriers in their legislation. So this is an ongoing work which we have started through a memorandum of understanding with Ukraine, and this, I hope this will further materialize one day also to concrete projects. Another important pillar, the providing incentive for biogas upgrading, since basically today we have only 3 billion cubic meters of biomethane, majority basically being biogas. So the idea is that we in parallel increase the production of biogas, but also the upgrading. So changing in some cases this would mean revising member states' support schemes in order to focus on upgrading. Since biomethane is the most efficient, let's say, energy use compared to biogas. Unimportant, obviously, in a connection or injection option, then this basically makes a project non-workable. So that's why there will be an effort to make this assessment, and there will be a task force also in the industrial partnership supporting this. That at every member state, regional authorities together with the distribution network operators and transmission network operators, they do an assessment of the areas where the potential lies for biogas, biomethane, based on the existing feedstocks or waste or existing projects or plans for projects, and to see what the connection capacity is, and basically to adjust the system into the future in order to support this. And very importantly, a huge sudden increase, we hope, of biomethane and its injection may basically technically be impossible if, for example, the system is not prepared to tackle with the increase, which also in some cases means a reverse flow in order to basically regulate the pipes. This also means quality standards for the gas to basically make it possible to, for example, to cross-border transfer of the biomethane. This is specifically about the oxygen content. So all these bottlenecks to be tackled to have a cost-efficient deployment of the biomethane. Also, there is a lot on the Horizon 2020, Horizon Europe on different aspects on small scale also, but the focus will continue identifying the gaps. There will be a task force in the industrial partnership as well in order to focus the future research specifically on the increasing the the efficiency of the small scale technologies, also focusing on new paths, a bit mainstreaming and further improving, let's say, the use of gasification of woody biomass, for example, based on residues and waste from wood.
Thank you, Galin, but I will have to interrupt
sorry,
you now.
I'm finished. Sorry for it. It's a lot. I'm finished. And the last pillar is about financing, where also we'll be involved in the European Investment Bank. Basically, a mixture from subsidies. The common agricultural policy through the rural development is a key, let's say, support, together with some financial instruments. Thank you. Sorry for being long. It was just a lot of information.
The insight of the European Union regarding the targets that may be reached by efficient biogas production, the rural development, the energy independence, and the greenhouse gas reductions that are possible. And the ambitions are high and have been accelerated by the crisis after Putin's invasion in the Ukraine. But we also see the issues of sustainability criteria, tracing demands, and so on, which may also provide obstacles to the development. We're now going to enter into the more technical and more Nordic perspective on these issues. And the first speaker is Morten Ambie Jensen from Department of Biological and Chemical Engineering at Aarhus University.
Thank you. Thank you very much. And good morning, everyone. So I will quickly run through focusing in on the green biorefinery technology, the green biorefinery system. A quick fly-in on what is it actually the technology is and can do, and the status at the moment, before we give the word further to colleagues. So, well, the green biorefinery is based on the well-known concept of green leaf protein extraction, where you have a green leaf, a grass or clover, you have a wet fractionation to a press cake fiber, and you have a green juice, and then you separate out the protein from the green juice and get a protein concentrate and a residual juice. This fairly simple operation is affected by a lot of parameters, the plant and the processing. And we have been working on this for quite some years in Denmark, and also in collaboration with Sweden for the last 4 years in the Green Valleys project. And I'm from the engineering side, working with the upscaling from lab to now demo scale, that we have been running a demo facility in Aarhus University for the last 3 years. 10 tons an hour maximum capacity of input of wet grass. So our approach has been to develop this fairly well-known technology in the sense that the focus on simplicity, practicality, and bulk applications to get it to work in agriculture. And setting up this grass biorefinery that produces a protein concentrate for monogastric animals, pigs and poultry, a fiber for ruminant animals, or biogas if you don't have any cows, and a residual liquid that goes very well in biogas, and you can recycle the nutrients back to the field. So that's the concept, and the drivers are environmental, for environmental reasons in the agriculture, for technology development reasons in the industry, and for sustainability issues in the feed application. A status in this green biorefining technology in Denmark, where we are probably in the forefront of this concept of green biorefinery. We've been working hard to get the quality of the protein concentrate good enough so we can substitute soy. This is now, we've seen that several times in feed trials, that we perfectly fine can substitute the soy with the protein concentrate coming from grasses and clovers. The fiber press cake for biogas and for ruminant animal feed is also okay. It's fairly easy to produce biogas from this fiber fraction, and the press cake works well as a ruminant feed, depending on the incoming raw material, of course, it will make changes. The commercialization is ongoing in Denmark. There are 2 facilities in Denmark that have been established commercial facilities, and within the last 2 years, they are running in the technology, working with it, improving it. It's still difficult or a challenge to have a really good, positive business case. So this is a focus area, and the reason for the not instantly good business case is that the yields of the protein concentrate can change a lot depending on the raw material, the processing, and it's often too low. And we are working hard both in Aarhus University and with the industry to improve these yields. And then there's a great potential in the 3 process streams of protein, fiber, and this residual juice that we call brown juice, in increasing the value of those, thereby increasing the business case. So the next 3 slides, I will just quickly talk about what we see as the possible increases in the different process streams. So if we take the protein part first, it's now a protein concentrate for substituting normal soy meal, but making specialty feed with extra high protein, optimize amino acid composition through processing or breeding of the raw material, get a value out of the lipid content, etc. Or, as we also are working on, change into food protein, so bypass the monogastric animals and go to the monogastric human beings. This, however, require more process development, and also for the food, a novel food approval in the EU, which is very important, otherwise there is no market. However, having high value products is good, and it helps the business case, but having low value bulk products really is important for cashing in on the sustainability aspects. For the fiber, which is now ruminant animal feed or substrate for biomethane, we could think of thermal conversion, pyrolysis, biochar, lignocellulosic biorefinery making biochemicals, biomaterials. There are works on insulation materials of grass, textile materials of the cellulose fiber, etc. So there are good possibilities in the fiber fraction, which is 70% of the dry matter coming in. And then the residual juice, which is now for biogas, using membrane technology, up concentrating the valuable compounds for fermentation, precision fermentation substrate, or taking out already available valuable compounds in this liquid residue. So these are what we see as the main value increasing technologies for the green biorefinery.
Thank you very much. An illustration of how we in the Nordic countries are actually doing things also. And Christel, I'll hand over to you to continue describing some of the other practical attempts to make these biorefineries real and profitable.
Thank you. Okay, now going to the biomass that goes into this biorefinery, which is grass clover, or actually it could be a pure leguminous. And the thing about this is that I have just started here to say something about crop rotations, because this is basic when we talk about agriculture. And this is some kind of an engine for when we're producing the biomass. And this slide shows what's quite typical in European agricultural areas. We have only annual crops, and it's dominated by cereals. And you have also winter rapeseed here. And the possibilities here to have this integrated in the farming land is actually to change crop rotation and get into 2, 3, maybe 4 years of grass clover. So you get a perennial crop, and then you go back and have an annual crop. So you have a higher diversity in your agriculture. And this actually has many, many positive agronomic gains. It's very obvious. And for example, soil properties, weed, biodiversity, and we could talk a lot about this. But it also actually ends up in higher yields. Having wheat after wheat compared to having wheat after break crop can actually have a yield increase of around 20%. So actually today we are having slightly too small yields because we have two bad crop rotations. Here is an example of biodiversity and pesticide effects if we have these two non-diverse crop rotation. We have, for example, increasing problem with resistant weeds and also pests like fungi because we actually have a bit too much cereals in the crop rotation. Here is one example. And this might lead to high yield cuts, actually. It's already doing this in some wheat growing areas in Europe. And if we look at the landscape scale, you can see here a picture from colleagues in France, actually, but it could also be in other parts of Europe or in southern Sweden. We have very few crop species, and this is bad for biodiversity. We know that increasing biodiversity will increase the biodiversity in the landscape. Another important of growing this grass clover is that it's perennial. And this is, I have learned from my Danish friends, it's very good, but showing just when you have perennial grass, we take 3 or 4 cuts per year, but you always have it green, and especially during winter time, you don't break it up as you do when you have this traditional annual crops where you have no or very little plants in the winter, which is very good for nutrient leaching and erosion. But I end up and just say a few things about very important, and that is the potential for carbon removals. That is to increase soil organic carbon by growing more perennials. And I will show you some example from Swedish field trials here, where we actually have looked at for 35 years, followed where we had a traditional only cereal, and then changed into a grass clover rotation, where we had 3 years of grass clover and 1 year of cereal, and it was actually followed for 35 years. And in average, we had quite, especially in the Skåne sites, quite high soil carbon increase. And it means that with this change, for 35 years, we're actually taking CO2 from the atmosphere and storing it in the soil. And to be able to do this significantly in agriculture, we have to grow more perennials. This is a quite big thing, talking about how we can have more carbon removals. But carbon farming is talked in this Green Deal. And I think it's very important now what we are going to work further on. But there are challenging things here. For one thing is that we have too few field experiments to back up. We use modeling, and the model gives different results. And there is a very big variation between different sites, which is how it is, can have to do with cultivation history. And you can look here, for example, exactly the same experiment, and you had a more than double higher soil carbon increase in average in this Skåne site compared with this Västra Götaland site. Just to finish off, if we think about introducing this grass biorefinery together with biogas, that would be very interesting, for example, in these very cereal-dominated landscape, and there are many of those in Europe, and they have problems actually. And we have just tried to understand what could happen in a landscape like this. We took Skåne, where we today have a biogas in Jordberga. We have data from our field experiments, and we have started now do quite a lot of calculation. What will actually happen if we would integrate more grass clover crops there? And Göran will continue with this afterwards discussion, but there are many things that are actually happening with the greenhouse gases when you do this system change. So you have here Morten's Green Biorefinery. Here we have a lot of farmers with potential to change some of their crop rotation. That is, change some cereals to grass clover and deliver biomass input for this green biorefinery. What will happen is that at the farm, we will have reduced greenhouse gases because of less use of fertilizer, and we have soil carbon increase. And then we will have protein that can substitute soy meal. We will produce biomethane, and we will have, very important actually, biofertilizer from the biogas, which will substitute imported fertilizers. So there are many benefits actually when you look at the overall system. So I will finish here now, and Göran will talk a bit more about these carbon removals and benefits. Thank you.
Thank you, Kristel. I think that what we now heard during these two presentations was first how interesting it is to study the opportunities of producing multiple products from a single feedstock. And then we heard how complicated it can be to actually produce the feedstock, because crop rotation is one important factor deciding what will be long-term efficient or even long-term sustainable in the production of the biomass. And you can understand the challenges of the European Commission and other European institutions trying to formulate sustainability criteria, and how easy it is to confuse the discussion. I will now hand over to Göran Bandes to talk more about the perspectives and experiences from Sweden, in your case, I assume. The floor is yours.
Thank you, Thomas. So just following on first from where Kristel ended here, and it's as an illustration of what you could achieve in terms of mitigation from 1 hectare here with this transition that Kristel described. So you will see you go from the cereal-dominated landscape to the rotation with more of grass clover lay, and you can, through the biorefinery production, then produce roughly from 1 hectare 1.6 ton dry matter of green protein and roughly 600 cubic meters of biomethane. And the greenhouse gas savings here, including then also carbon removals, since we build carbon in soils and possibly in biomaterials, you would be, this is a ballpark number. It depends much on how you use the products and what you displace. But just to give you a sense from what you could deliver here. Also wanted to show you pictures of the heroic modelers that derive all the numbers that we talk about. So Sebnem is here today. Andreas is not here. I think he's probably busy with modeling. When we talk about Danish-Swedish perspectives, I think, as you will see also, the strategies for green biorefinery development will look different in different countries, since conditions are also different, and not only natural conditions, but basically the structure of forest and agricultural industries, and also in general energy infrastructure, and not the least political goals. What you see here is actually a global picture from the IPCC 1.5 report, just showing in principle what most countries need to achieve in moving towards ambitious climate targets, where you need to phase out fossil fuel use, of course, but also change land use, and in many places probably aiming from converting land use activities from a source of emissions into a sink for carbon, which is then something you can be more or less successful depending on where you are in the world. Then if you look at approaches to try to do the transition and how that has been, you could say, interrupted or through now a difficult time due to the Ukraine war and the energy crisis, you could see unfortunate distraction in some areas from the strive to reduce emissions. But hopefully what you will see with this red curve here, it will eventually turn right up and improve both energy security and greenhouse gas performance over time. So let's hope that we are now in a phase where we are just learning how to do this better than we are doing currently. And here green biorefineries, I think, can be an important part of that. Then I want to just spend a couple of slides explaining my question mark here for the Swedish perspective, how green biorefineries will evolve. I think we can say for certain that we will play towards both the transport sector, but also the industrial sector and materials production, and also heat and power. So bio-based materials and bio-based energy will be important in most sectors in Sweden, and we have also recognized that there is almost a competition for really having the privilege to use the biomass feedstock for your own sector. That's part of the Swedish debate, at least, where to use the biomass. When we think about green biorefineries and where we see a place for it, we need also to keep an eye on other developments. And just to illustrate that, this is another group at Chalmers working with thermochemical conversion and supporting the transition in the petrochemical industry, where you also need to move away from fossil fuel-based systems, and where you probably, if you implement this in a wise way, can actually gradually close the carbon material cycles while shifting from fossil carbon to green carbon to become much more climate friendly, but also resource efficient. And of course, this is a huge development that green biorefinery development needs to relate to find its own niche in Sweden here. The other example and diagram that Crystal told me to rip out of the presentation because no one will understand it anyway. And I said it's not a problem, just read what Björn Sandén say and you will understand also the diagram here. It's illustrating how carbon-based alternatives to scarce metals are becoming more and more important in development. And you can see new carbon-based materials like this that probably will lead to what you would call bio-based applications in new places you wouldn't expect just a few years back. And just to give a few examples here on future bioenergy systems, or if you would like to call it bio-based energy systems, you might see electrofuels that are produced from renewable electricity and probably biogenic CO2 that has been captured from CHP plants. And then you would start thinking what is really bioenergy and what is really bio-based. And you see you have many other examples where bio-based systems can actually be part of renewable energy systems, but not the type of bioenergy that we have traditionally looked at. I think a few things just to round off here. What I think we can be certain about, and we have discussed it quite much in the Green Valleys project, that is that we, as Morten also said, we need to really figure out what to do with all the resources that we bring into the green biorefineries and how we can develop products, and not the least products that really preserve the properties of the biomass, because that's probably where we can have a competitive edge against other carbon-based materials. We have thought about textiles as one possibly important application in the continuation. Carbon storage in soils and ecosystems, as Crystal talked about, we need to consider that as a long-term commitment in land use, because the carbon will stay in the soil as long as we manage the soil wisely on the longer term. If we change land use again, we might lose the carbon. So we need to develop sustainable land use systems that deliver products that we want on the long term. And here we believe at least that the type of rotation changes that we have looked at in this project, they are examples of really promising sustainable land use systems. So Thomas, I can finish here, or I can show 3 slides on how we can save the world from all evil. It's up to you, actually.
I give you the 3 slides, without doubt.
Okay. Just to illustrate Now going to the European level and showing how you could approach and explore the possibilities for grass-based rotations or also other lignocellulosic crops. What we have done in a few years now in studies that we have targeted problems of current agricultural land use and investigated how you could expand alternative land use systems, such as the grass-based systems, to address the environmental problems. We have looked at soil carbon losses, which has been going on for quite a long time, nitrogen emissions to water, soil caused by water and wind, and also problems related to recurring floods. So these are examples of challenges that we face in Europe, where a land use change might actually provide a mitigation solution. And then we have calculated how much biomass and thereby bio-based products that you could produce if you implemented that on a large scale. And here just, of course, many different products, but just connecting them to the REPower EU target. And again, this is a ballpark number now. The biogas that you could get from a large-scale deployment here of grass clover lay, it's roughly the same total volume as you actually have as a target for biomethane in Europe. Not saying that this is a silver bullet that will deliver all gas needed, but just to illustrate that it's big enough to be taken seriously and looked at more carefully.
Okay, so not all evil avoided.
We'll see.
But what you're saying is that the soil effect is the same as the fossil gas replacement effect, is it?
So this is a biogas production from the grass that you produce, while you also reverse the soil loss process. So that would be an additional climate benefit besides displacing Russian fossil gas. Yes, no import of soil, and all the rest of the evil in the world, as I say. Okay, thank you.
Thank you, Göran. Wonderful illustration of the further opportunities also in the technology sector, where carbon-based materials may play a very important role in replacing what is today metals, sometimes scarce metals used. Okay, Ulf Jørgensen, the floor is yours.
Thank you. I think I'm on, yes. I will scale down from the European level to a small living lab called Denmark. And as you can see, Danish agriculture has developed a lot, we think. But which one? That's the one. Actually, our agriculture is highly contested. We have a total land cover of agriculture of 62% of the total area of the country. 80% of that land is in annual crops, which are the bad ones. We have a long coastal line with shallow fjords, and we have to tackle the EU Water Framework Directive, EU and national climate policies, groundwater protection for the drinking water, and we have poor biodiversity. And finally, this agriculture is not really resource efficient, which might be the only thing that might be surprising, because the other things are quite well known. You think this is really very resource efficient with such a big harvester and a very efficient wheat field. But look at it, it's not green. It's in the middle of the summer where we should have photosynthesis. And that's something I want to stress again. Most of you have probably heard me saying it before, but I cannot say it too often, that photosynthesis is what we live from and what we will have to live from in the future, because this is the most cost-effective and scalable process to capture carbon and to deliver food, energy, materials, and negative emissions. If anybody disagree with me, I would like to know if I'm wrong, but I still think this is correct. And those technologies that we've seen in the morning, and with this focus on increasing photosynthesis from that level of losing almost half of the potential production of an agricultural landscape in Denmark, because the agriculture has not been developed from a natural point of view, a natural science point of view, to maximizing carbon capture, but in order to promote some specific products that was valuable for the market, and wars and things have developed the agriculture. So now we could think about developing it from a natural science point of view. And therefore we have been doing some different scenarios of how Danish agriculture could develop into 2030 and 50, where we have some goals to fulfill. We did business as usual, just doing more of what we have been doing for a while, using more and more of the manure for biogas and the straw for different energy purposes. We've been combusting a lot of our straw, but now we're using more and more of it for biogas, and that we could do more. But then we have optimized in the biomass scenario a lot of agricultural parameters, like changing from less effective crops into more effective crops to increase the size of the cake that we can share, the total biomass. Also, we can choose some varieties of grain crops that have more straw without compromising the grain yield. And there are many, many small things that we can do. Then we also, because this is maybe too much productivity, we also have an extensification scenario where we have much more focus on nature. As you saw, we have very little nature in Denmark, and there are some EU regulations also to increase that. So this is the focus of the third scenario. And then we also address the elephant in the room, the animal production, which is starting to becoming more and more debated in Denmark, whether we should do something or not, let the market rule or not. But at least it would be nice to see what it means. This is just one slide to show what could happen in a Danish landscape if we would try to fulfill the European Water Framework Directive by increasing the production of grassland in the most nitrate-sensitive areas. Then the more dark the color, the more annual crops have to be changed into grassland. And you see north of Copenhagen, everything has to be changed into grassland because there's so little grain crops already. So, and there's a big challenge to fulfill the Water Framework Directive in that area. But otherwise, it's around the fjords in the western part of the country that we have the main challenge, and we can do a lot by increasing grassland area. And then, quick and dirty, the results from a long story on our scenarios there. As you can see, or I can tell you that today we are producing primary products of that can be eaten by animals or humans in Danish agriculture of something like 15-16 million tons of dry matter. Then we use bio resources for energy and other material purposes like 2 to 3 million tons today. Then our scenario shows that we could produce and use another maybe 10 million tons without compromising environment and climate. I haven't got the time to go into those details, but that's something we also calculated. And then there's a lot of variation between the scenarios, but you can see we could also take the extensification scenario with much more nature without losing the opportunity to still produce much more biomass for the bioeconomy. We have allowed an exchange on our import-export with the scenarios. Today we import a lot of soy, as you can see in the reference 2015 to 19. But on the other hand, we export some grain. That changes in the different scenarios, but it also shows that we could reduce that import of soy significantly, even in some scenarios totally be self-sufficient in soy even though it's a large amount that we import at the moment. Finally, I will not go into any detail, but just like to show you that now we have it all, and we have solved not the evil of the world, but at least for Denmark. This is the carbon economy of Denmark in 2050. And we have all the products that we need to the right. We have the inputs to the left. We have the carbon storage to the bottom. We have the atmosphere in the top. And this is zero emission in a fully electrified system. One detail is quite important because direct air capture of CO2 will probably be something that we need to do in order to get into zero emission and have the products that we need. And this is maybe the box that will change with the different scenarios that we have. How much direct air capture do we need to take into the system in order to fulfill what we need from the biomass that we take in? What is also important to look at is the energy need for hydrogen in order to upgrade that bio-CO2 that we will get from the many biomass resources. That is a lot of energy. It's at least 3 times the ambitious plan we have now for energy islands and a lot of wind power. So there's a lot to do, but also big potentials. Thank you.
Thank you. I'm glad you didn't go into detail on all points. So we have now had an introduction by 2 representatives from the European Union. We've had several presentations on what is actually going on industrially and research-wise in Sweden and Denmark. And we're now returning to 2 presentations from policy makers.
Okay, thank you very much. I'm working with the Ministry for Environment in Denmark, and I've been also working for the Ministry of Food and Agriculture for several years. And today I would like to give you a view from the policymakers on this magnificent technology that we've been presented during the day. So first of all, a few words on why we see this technology as an interesting technology, and a bit of status of what has happened here in Denmark and where we are now and what we would like to see happen in the future. So it's obvious seen from our point of view that what we can benefit from promoting this technology has several aspects. I mean, recently we have adopted an action plan against deforestation, in which we have a ministerial governmental ambition of increasing the amount of self-sufficiency on the protein in the protein area. We also see that we have a huge problem with fulfilling the Water Framework Directive in Denmark, and we see this technology as delivering results. We also have challenges with regards to the water quality in the different areas in Denmark, and we also know that this technology can help in this regard. And finally, coming in, we heard several times today, we have a huge gap in carbon supplies in the future, and we see that this technology will and the crops that we need, the grass can supply us with more carbon per hectare than we have from agriculture crop systems today. A few years ago, the Danish bioeconomy panel handed in some recommendations for the government on the proteins for the future. In this plan, there was an ambition set for increasing the national production of green proteins significantly, and these recommendations from the panel has been adopted by the government and has been turned into an action plan. This is now a couple of years old, but it has driven a lot of the investments in this area that we have seen in the past years. Okay, so During the last 5 to 6, 7, 8 years, we have seen a lot of different initiatives in this area. And all total, I think we have invested about 15 million euros in green biorefining and these value chains. So a couple of years ago, we had a lot of interesting headlines from the newspapers. You can see here that a lot of people recognize that this technology actually has a role to play in the future. And I know that many of you can read Danish. So, and those of you who can't, will just say that this is very positive headlines from the Danish media. And also as a result from both the development projects and also the adoption of the Danish action plan, we saw that the business sector gathered in this Danish protein innovation and adopting the same ambitions that we saw from the panel. And it was something around substituting 1/3 of the protein imports with more locally and more sustainable protein sources. One of the most recent and closest to commercial adoption is the Biorefinery project and the Ausumgaard project, where we have some two larger scale facilities in operation. I think they are both up and running, but struggling to get as Morten mentioned before, struggling to get the business case improved. And from the research area, I think the area here has also been adopted in the Danish strategic plans for doing research in the area. So we are quite happy about it, both the protein area and also from the EU side. I think there's a lot of opportunities that I hear from different sources that are from different sides that we maybe not have developed or utilized fully yet. I mean the CPE joint undertaking, for example. So when it comes to policy, of course, as we heard before, the EU Green Deal has been kind of a headline for all the countries in Europe. And since we had the new government 3-4 years back, there was adopted a climate act where we had all the different ministries had to make the action plans on how to deliver the very ambitious climate goals. So last year in October, we had an agreement on green transition of the Danish agriculture, and it has been a historic agreement here in Denmark because it's a very broad constitution behind the agreement, and it was also quite ambitious with a quite serious cut in the CO2 reductions. The agreement has also been criticized a lot for being not very concrete, but a lot of the content of the action plan is actually from development initiatives that we don't really know yet, but something that we hope that we will see the benefit of in the future. So when this agreement was made, it was also had a lot of environmental content in it because we are struggling to fulfill the goals in the Water Framework Directive. So, with regards to the green biorefinery and the production of green proteins, I think this deal that we have, or this agreement that we have in the agriculture center area, consists of a lot of different parts. As we could just zoom in on some of the most important here, and that is the CAP investment scheme for biorefineries, where there's been set aside 35 million euros to an investment programs where consortia and businesses can get co-financed to implement and invest in these green biorefineries. So the idea here is that these refineries are very important in creating this market pull for a shift in the way we have the agriculture rotation system, so we get more grass in the fields in Denmark, and that will deliver towards the Water Framework Directive as well. So this concept has been backed up by an eco scheme. We heard that from the Commission previously. That is one of the tools in the box. So there's an eco scheme for grass in Denmark, and we have. It's also been a part of the deal that we have to develop. There will be developed a national protein strategy, setting targets and initiatives for driving not only grass-based protein products, but also other areas such as insects and legumes and whatever. And moving this area further, the National Bioeconomy Panel has been relaunched and has been given the task to look specifically at the role of the bioresources in the green transition. And Uffe previously showed a few slides from that project as well. We're trying to develop a more kind of holistic approach, looking across sectors, energy, transport, and food and feed, and seeing how can we actually prioritize the use of bioresources, and how can we optimize the production of biogene CO2, carbon, and resources from agriculture. So, interesting, I think, is looking towards the energy and climate policy. We heard from the Commission today that biomethane is a huge investment area coming, is existing already, but increasing a lot in the future. And we see a lot of investment from both private and governmental side in increasing the production of biomethane and biogas at the moment. And I think that one of the ambitions for us here is to look to the other ministries and explain them how this green biorefining technology is important in order to get more bioresources to fulfill all the different needs in the different areas. In this way, by improving or promoting these biorefineries, we can actually produce a lot more residues that could be used for energy and material purposes. So to wrap up, I think a very important point is that we have to look across the different ministerial areas, the different sectors, and see how we can combine these very promising technologies with the climate and energy area. And we hear just last week we had some temporary recommendations from the bioeconomy panel. These will be made final next month, and they will also be translated into English. And some of the main recommendations here is that we need to improve and increase photosynthesis on the agricultural soil. And Uffe showed some of the graphs before, and see actually how large the potential is. I think the biopanel is pointing at an extra possible resource of 9 billion tons of dry matter. So that's quite significant. So the bioeconomy panel also points at the possibility of using this technology to actually give space to some other goals, such as nature and biodiversity, by using these extensification scenarios. And very important also that we need to look at the incentives that now drives the bioresources for energy purposes. We need to have a look at how we can manipulate and direct these incentives so they can actually support the biorefining of the biomass before the residues get utilized by energy. So just a few, this food and feed regulation, I think that is one point that we need to look further into, that we hear from the different sources that are different sides, that it's a challenge to produce these new kind of food and feed because of the regulation. I think that's about it. I hope that was not too long.
Thank you very much, Espen. We have now heard from the Danish Ministry of successful, almost total agreement in Parliament behind a strategy on energy. We will now go over to the Swedish Energy Agency, which is not a policy-making ministry, but a statistics supplying and policy advising agency. And hear what Kalle Svensson has to say about the Swedish setting, where the parliamentary agreement is not quite as good.
And yes, thank you for inviting me to this seminar. And I'm sorry that I couldn't make it to Gothenburg here today. Too much to do. And I will give you a short introduction here to some of the policies that we handle at the Swedish Energy Agency. And first I will show you a few slides that go through very fast because there are some basic information there. And to come to the real there, yes, now. Yeah, it's just a few data about Energy Agency, and interesting perhaps is that we are here is 440 employees. I think we are more than that now, and we are approaching 500, growing thanks to Russia and other things. And yeah, we are based on a few political goals that are priming our mission here at the Swedish Energy Agency. And we have also 3 pillars of Sweden's energy policies. And that is environmental sustainability, symbolic by the tree, and the competitiveness, and security of supply. And to reach those goals, and so on, we have some tasks and tools at our hand at Swedish Energy Agency, and you can see Thomas mentioned some of them. And some important policy instruments, of course, directives and from EU and the Swedish laws that come from them. For example, Fuel Quality Directive and Renewable Energy Directive, and they are transformed into Swedish laws. I will not go into these details, but we have, for example, control systems and so on at the Swedish Energy Agency. And for example, also information is one example that for information on fuel stations about the environmental performance of fuel. And I personally is working at the energy and research funding on bioenergy. And here is just the example that we are boasting our results of the project that we found. So just that was the short introduction of the Energy Agency, and now I come to what we here to talk about. And I will first show you this picture. It begins. I want to begin to explain how we prioritize our bioenergy fundings here. And we have a general model of bio-based value chains, and our strategy is to focus on the waste streams that comes from these different bio-based value chains to produce different fuels. And of course, the plant nutrients should go back to the primary production. Of course, we have some kind of, it can be some kind of recirculation here also. And one example of this thinking is a project here where we have funded research to produce fibers from poplar. And then there will be some waste products through different processes here, and bio-oil, for example. And they are used for energy purposes. And if you look at a ley-based value chain, thinking about that, the problem here, so to speak, is that there is not too much waste to speak through this value chain if you are a very competent and skillful farmer. And if you use the fodder, of course, the manure, and you can use fuel from, as we have heard here, biogas a few times during the morning. And but if you use it for a biorefinery, what will happen then? Because if you use waste, then there's no problem with different things like renewable energy directed, for example. So, of course, a biorefinery will produce fuels. But if you are a CEO of a biorefinery, you have to be aware of a number of policies. Here is a question mark. Could there be any fuels? And first, you have to be aware of CAP, for example, and other things that is important for primary production. And as the CEO, you should also be very aware of different directives and so on that will steer your production part here, like the sustainability criteria, the emission reduction obligation, biogas production support, and investment subsidies, and so on. And of course, you want to develop your process and plan, and should be aware of all the different research and development funding that we have at the Swedish Energy Agency and other parts of agencies. We have, for example, BioPlus. We have a pilot and demonstration program. We have Industry Clean in Swedish. It's an industry support scheme. And we have a new strategic program here, Impact Innovation, and so on. And the important thing is here, of course, that research forms the foundation for new policies also. And you can read a lot in this program, Förnybara drivmedel och system in Swedish, renewable fuels and systems. One thing that is important also that I want to stress in this policy landscape, but I haven't seen anything yet, is the plant nutrients. How should we promote the recirculation of those? And if I summon the potential problems or obstacles that I have been thinking about when I think about this biorefineries is these things. It is a new and integrated industry, and there are no strong supporters yet. In Sweden, we have a lot of different organizations that support established industries, but biorefineries have no such organization. There is a need for dialogue between the governmental agencies, and that might be a challenge, really, because of this integrated character of this industry. And we have also changing policy landscape. When is really the right time to build this biorefineries? And ley is a rather narrow feedstock basis also, if you see it as from a process industry perspective. Should broaden it. And last but not least, is all ley cotton sustainable? I haven't got the answer on that question really from my colleagues.
You have 1 minute.
Hmm?
You have 1 minute left.
Yes, and actually I am finished.
Excellent. Thank you. So, we heard there were some problems in Sweden and some ambitions in Denmark. Now it's time for a panel discussion with all the present speakers in the room. So please come up here. It will be a standing panel. Those who have microphones might bring them. I think they will work in parallel. And then we have one handheld for the rest of you. You take that as a start. So I think we heard in the beginning the very determined support from the European Union and the European Commission and the multiple purposes of successfully developing green biorefineries to substitute imported protein, to substitute imported energy, and to substitute some materials. There seemed to be agreement in Denmark amongst your political parties that this was something that was actually going to be carried out. A slight complaint that it was not so concrete and specified exactly what was going to be done, but at least the ambition was there. And they were heard from Sweden that there was a bit of confusion and a lot of obstacles. At the same time, though, I think we may say that if you measure it in tons of biomass converted, Sweden is doing quite well, aren't we? Göran? Exactly. And the right. I didn't say better. I suggested bigger. Yes. But the Danish.
Could I just say something
yes.
here? I think that it's very. I think it's very interesting to work with Denmark because we are so close, but we have very different opportunities. But it's different in different parts of Sweden. I mean, if we look at south of Sweden, it's. I mean, we were in Denmark before. But anyway, I think that what is very important for us, we have been lending back and say forest will fix it and agriculture can do whatever. We don't care about agriculture in Sweden. However, the forest discussion in Sweden now, we don't have any growth. The growth is actually slowing down in Swedish forest, and we have a massive discussion around biodiversity. And so I think it's very important that we start to speed up in agriculture. And I don't think we are ready for that, actually, in authorities, etc.
One of the issues that have been brought up several times is the importance of carbon accumulation in the soils. And to what extent is that important in the Danish policy process now? I think it was not as clear as in some of the other slides. What would you say? Any of the Danish?
I think it's a high focus, but so far focus has been mainly on the other greenhouse gases like nitrous oxide and methane. It's part of the process, I think, to get also the soil carbon included in the regulation. It's also a difficult area because, as Jørgen said, it's something that we can store and then we can lose it again. So we have to think over a long time what to do. Then biochar is, of course, a solution that is interesting, and that development is going fast. That's one of the development initiatives of the Danish agricultural law, whatever it was called, from last year that was criticized because it's still under development. But there are some companies taking it very serious and scaling up at the moment pyrolysis plants to use mainly straw, but also residues from biogas plants. I think we need to then discuss whether that carbon that we have already in the industrial circle is best suited to get back to the soil as inert carbon, or we should use it rather in the technosphere for materials. I don't have the answer, but I think that's what we were trying to look at with those full carbon economy slides that we have been doing for Denmark. Where do we best use our carbon resources?
While Morten is commenting, if you have any questions, let me know.
I was going to talk about pyrolysis, but Uffe did it very nicely. So.
Okay, now, first question from the floor.
Hello, yes. Timothy Benham, Chalmers University of Technology. My question is to Laurent. I've understood that there is, since the early 70s, a GATT agreement, which means that there's no import tax on soy and other legumes into the European economic area, which puts European farmers at a disadvantage economically in producing proteins in Europe. Is anything being done to change this?
Yes, well, it's true that there is no, but there is this discussion about new policies when it comes to carbon border adjustment taxes. To actually, if you can't produce, and that could be steel or anything, if you can't produce at the level of EU, you have a tax when you import. And that would be very interesting if we would look at models like we do here and see what would be the cost of soy meal if you had the extra, compare it with green protein and compare the overall extra carbon that is actually emitted. And then the economy would be less good for soy meal, I can say for sure. But this is all discussed now in the EU, and I think that the French government is actually driving this quite hard. And question is how fast it will come, because now everything goes so fast because of the geopolitics and everything, and about food security. And so there are discussions.
It seems Espen wants to comment on this.
Oh, that was basically to the question that Uffe answered. Just very briefly saying that it actually. It has been agreed that the agriculture in Denmark sector has to cut significantly, and one of the means to do that is the development of a regulation system on individual farm level, where the farmers have to cut the emissions and to store carbon. So I guess that this would be a very important driver for this technology. This is still under development, and that has been, of course, been criticized a lot. But it's coming, and in combination with the carbon tax that is also hitting the agriculture sector, I think some incentives are rolling out here that could be quite efficient, promoting these biorefineries and grass agriculture.
Thank you, Espen. Another question from the floor, Bo?
Yes, there was a report this summer that in Gothenburg, a large part of the food requirement could be covered within the city because the city owns a lot of land. Has there been any questions how to combine that sort of with what you put forward here now with the green biorefinery and grass?
I'm sorry, I didn't.
Oh, sorry. This report that came this summer that was a loss. The food requirement of Gothenburg city could be to up to 50% be covered within the city because the city owns so much land. And what you have described today, could that be combined with sort of the food and green biorefinery locally?
I don't know about this exactly, but what I understand, Gothenburg has many areas where they can grow agriculture. And in discussion, I think it was more about plant vegetables and vegetable sources. But I really think, and I could say to Morten, I mean, we have looked at grass, clover, and lucerne. But could you think about this biorefinery using other green tops, for example, leftovers from green vegetables, etc.?
Yeah. Yes. So, and this also relates to the last question that coming from the Swedish Energy Agency. That is it only grass? And technology-wise, it's definitely not only grass. This is a technology that could be applied to any green leaf biomass material. So it's the protein that are in the green leaf photosynthesis that would be in vegetable residues as well, and the wet fractionation and use of the plant liquid is very general, and you could use the same equipment for adapting that.
And I think that if you look at this land, I think what we talked about also with Gavin with the biomethane and rural structure, we have to have many small plants and in a good way connect them to the grid so we can upgrade and connect the biomethane to the grid, or you could use it locally, but you have to have both options. And I think you should see this as, okay, ley and grass clover is the main, but there are other sources, and you should have very different areas. And I'm sure that could fit in. For example, what we have calculated in an example, we had like taken in 9,000 hectares per year, and that is kind of mid-size. You could have a smaller one, but if you connect, and that could you have, depending on the area, you should have some kind of rural where you see many of these small plants.
Yes.
Another comment to the question that relates to what could be the municipality's role in this, or the local authorities. And in Denmark, we have been approached several times by municipalities that have land where they can decide and make rules what to grow, and they think this technology is really interesting because if they have problems in areas where we are having drinking water taking up, the grass and clover production there would be much better to have than annual crops. So they have an interest in the drinking water quality, and therefore could push some of the area.
Thank you. Göran?
Can we have questions from the panel too?
You can have a question, yes, please.
I don't know, do we have Gallin left or any of the commission people?
I think you were still...
I'm there. I'm listening.
Yes.
Okay. So I'm a bit curious about when you see these integrated systems producing a lot of products, and they are to evolve now under a policy regime where we say, for instance, we have a very, very strong focus on residues and waste as soon as we produce energy carriers. And then, of course, Danish government is very smart, so they define part of the biomass flows within the biorefinery as waste, and then it's okay to produce fuel from it. But in my mind, this is just a kind of a play to make things acceptable, and it would be really interesting to understand if Commission considers other routes for enabling these multi-product biorefineries to run economically and from resource point of view effectively. So that's a question. Do you see anything in the new initiatives related to, for instance, the biomethane targets, where you open up for other ways of solving this, as I would call a problem, that it has to be waste and residues all the time as soon as you think of biofuels?
That's an interesting question. It reminds me of my own old question: how many French fries per cubic meter do you need to have in the oil to make it used? Gallian, do you want to try to answer?
Yes, I'll try. It's quite actually difficult to say that to reply to that question, but in reality, we have the cascading principle. It's also in the biomethane action plan. So one of the problems, as you mentioned, is that waste and residue could be, let's say, waste in one country, in one member state, but not the same thing could be labeled differently. So this will try to tackle. There are many different tools playing together. The certification, as I mentioned, and there is the Annex 9 list of the Renewable Energy Directive, and we'll be trying also through the Union database to impose or to kind of harmonize and impose a certification of the source. So the same thing could be labeled in the same way. Obviously, when we say waste and residues, some residues that they can be actually used for food. So we'll have to let's say apply this policy in a good way. So basically, through the work, I think everything which was discussed today actually is quite, I would say, important and could fit into the work of the task forces of the biomethane industrial partnerships. So I would let's say encourage you to take part of this work and to let's say to follow the work, to apply also for after the 28th of September. So where these discussions will take place in the task forces. So what residues, how, what technologies. So obviously grass-based is more for the let's say northern part of Europe. In the south, like in Italy, you have other, since the cropping season is a bit longer, intercropping or using intermediary crops is another option of creating additional biomass. But in any case, the objective basically is to avoid these discussions of how to say conflicting uses with the specifically residues used from agriculture or from the food industry, used for further extracting the nutrients. So the cascading principle should be respected. But it's the problem, I think, is that there is no one silver bullet, because there are basically many different areas interconnected. So it's not, you cannot solve it through one legal act or something. So we need to see specifically through the certification, to the different let's say lists that promote the advanced fuels, then to find a good balance, I think. I hope I tried to reply to the question. I hope that's what.
Yes, don't worry. We know it's difficult. Kristen.
Yes.
Okay.
Coming up on that one, I was so impressed by Espen's way how you modeled, where you put green protein in the middle, and you had all these different legislation and research and development that has to be done, because that is as far from this silo principle as possible, because we have to integrate everything. It was very, very much impressing, and I will take, because I do some work at the Jordbruksverket in Sweden, but I think we have to think about this holistic way of looking at. Otherwise, we will never come forward with our agriculture. That is, I'm quite sure about this.
I have two questions in the room.
Thank you. I actually represent the architecture and construction industry and research within that field. So I'm very interested in whether there is currently any ongoing research on new material solutions that could be applicable in that type of way, in product design or in architecture. Because in Sweden there is quite a lot of interest on new materials based on the biomass derived from the forestry industry. So I wonder if the agricultural materials could also be a part of that development.
Thank you, Morten.
Thank you. Yeah, I will answer that. So we definitely see that this huge biomass resource potential that grass can have in agricultural areas or grass-like crops could play a really important part in materials, as also Jørgen mentioned that there is really a possibility in keeping the quality of these biomass components, the lignocellulosic content. There is not too many activities going on we're trying to increase the amount of projects that deals with this processing of the fiber for biomaterials. We have in Denmark a few looking to packaging material and for textiles. However, they're not very big. so and this is a big task. So it really would take an effort. But I think there is a big potential in building industry, but yeah, and in packaging and in textiles.
Could I add just a short comment? There is a huge interest also in Denmark actually in this area, and I think the discussion is probably slightly different than in Sweden because we have much more agriculture. There's a recent report from an agency called Realdania that tries to cover the potentials of biogene materials in building and construction. But we are starting a little bit from scratch. I think there's one interesting thing you could start with, which is easy, that is thatching, using straw, old technology, but you can make fantastic architecture by thatching also walls and combining with glass, steel, concrete, and then thatching, you make some fantastic things. But look into that report.
Yeah, and there is a lot done at Chalmers, some more practical implementation of those kind of opportunities, 3D printing of houses with biomass-based materials, for example. Another question.
Hello, I'm Parth from Chemical Engineering Master Program. So I just had a general question. Like, as you mentioned in the slide, that currently, if like in the green biorefinery process, the protein yield is comparatively low. So then I just wanted to know, like, then how much extra raw material or crops would it require to match the present like system which we have right now?
Yeah, so the yield the yield issue, I brought that up because it's very urgent in at the moment. But it's not. We don't see it as a challenge that can't be reached. It's just we need more development and especially process skills at scale to make what we can see is fairly easy in the lab to get that in large scale on a continuous basis. So that is the yield challenge, and it has a lot to do with being certain that you have a good quality of raw material coming in all the time, but weather and logistics and things that makes this a difficult task. When you have it right, then the yields of protein concentrate should be around 15 to 20% of the dry matter coming in is going to the protein concentrate, and about 40% of the protein ends up there. And we think that is realistic to make happen in a short time, but it's urgent for the industry that already started that this happens soon. So we don't see that we need a larger area. We need to improve the technology. Yeah.
Thank you. Last question.
Hi, Eva-Lena, and I'm a project leader for a project for local proteins for human food. First, congratulations to a great project. That is one of the best projects I have seen that really taking care of the system change of the transition we need to do. And I have a question for you. When you think about the future to accelerate this transition, I understand you have some challenges with our silos. What do you need to accelerate your ideas and projects?
I know what Christer will answer. More farmers. At least we discussed yesterday how we could continue working.
Good, because I have the contact with the farmers.
Yeah, no, but really to make much more efforts in having more of stakeholders involved and including farmers in our processes. Also learning not only from our side pushing solutions maybe, but also understanding their pull for solution, what is it they ask for and what would make them interested.
Yeah, I think I will soon leave us to Denmark, but of course more farmers. But I think that what I again said, I was so impressed by this green protein and all the stakeholders, legal authorities to go in the same direction and see all this holistic and where you have this multifunctional positive things. We are too bad at that in Sweden. And I'm a bit worried about we sit in Energy Agency and Agriculture and Food, and everyone agency, they can't work together. And I think that what we have seen here for Denmark is a perfect example of your bioeconomy thinking. And I also want to say what we need is very much, I think that what Morten has done for these 4 years, increasing protein in the soil, in the green protein, so it can replace and actually develop, that is well taught, so we are very grateful in Sweden to have learned from him. But I want to say, if you would get some lot of money, what would you do? I mean, because we have to do technology. Just
yes, thank you for that. I appreciate. No, I think what is really important to make this a really big market pool is to have a food product. Some of this protein could be used for food, and that would change the business case completely. So that would drive the market pool quite a lot. But that needs also novel food regulation that can take time, things like that. So development for that. And then I think that that these support tools for how to use the biomass in its best quality with the biomaterials, I think that's really, really important, and use the residuals for energy.
Thank you. And I would like now to thank all the speakers today for the heroic efforts to actually keep to an extremely ambitious time schedule. And we have almost managed. First, we were going to end at 11:30. Then we got another 15 minutes allowed this morning, and I think we are going to succeed. What we have given a lot of attention today is the production of protein in these biorefineries. And that, I think, is a result of the geopolitical development in the last few years, where the import dependence of soy protein and some oil protein has been given a lot more attention in the last year than it has for a long time. But what we've also learned is that biorefineries are wonderfully complex. They offer complexity in the variety of potential products, and they offer a wonderful complexity also in the feedstocks and the rotation that is efficient behind the feedstocks. And some people will look at all these complexities as horrifying, whilst I see them as wonderful opportunities for development. But I think what is also extremely important is what we did discuss with Galin and others from the policy-making perspective here, is that when policymakers are introducing various constraints or incentives that are not always sustainable over time, this is creating a lot of difficulties for those who want to develop these biorefineries, because also these biorefineries are often rather investment intensive, and the uncertainties provided by the varying prices on the many different markets that are involved are bad enough for investments. But the policy uncertainties that are introduced by, for example, these issues of definition of what is a waste product or a byproduct or a co-product, and what is allowed depending on different political priorities, is making it maybe unnecessarily difficult. But I think we've also heard that the scientific and engineering development ongoing is quite promising, and there are enormous potentials in these complexities. And I just wish all of you good luck in the future development of these opportunities. And I wish that the policy making, at least in these Nordic countries, are providing the reasonably stable conditions that makes investments in these processes possible. Thank you very much, and good luck with the lunch before the congestion fee at 12 o'clock at some restaurants. Thank you.